we'll be talking about what an endothermic and exothermic reaction is all about. So, the word exo means external, and the thermic means heat. Okay, so the endo part is endo means internal, while the thermic means heat as well. So, exothermic reaction is or involves the release of energy to the surrounding. Okay, so the endothermic reaction, in the other hand, has to do with absorption of heat from the surrounding, and the delta H is positive. Delta H means change in enthalpy. Okay, so let's look at the energy level diagram. Now, in endothermic reaction, the reactant is lower than the product. You can see this is the activation energy, and this is the change, the difference between the product and the reactants. Okay, so in endothermic reaction, the delta H still remains positive. And then in the exothermic reaction, the product is lower than that of the reactant. The energy of the product is lower than that of the reactant, so energy is released to the surrounding. That is why delta H is negative. Now let's look at the phase changes that occur in endothermic reaction. Number one, I have ice melting to water. When an ice if an ice wants to melt, it has to absorb energy, heat energy. It will absorb energy for it to melt to water. Okay, so as an ice absorbs energy in form of heat, it goes back to water. And likewise, liquid. If a liquid, let me use an example. You are cooking at home, and then suddenly the water you are boiling start becoming steam. Yes, steam. So at that point, it has received an energy, heat energy, and then it became gas in the form of steam. So when an environment gains heat, that is an endothermic process. So generally, the breaking of bond is an endothermic process. Let's look at this calcium oxide. So when a calcium oxide is being heated, when it's heated, it breaks apart into calcium ion and oxygen. And also, evaporation is also an endothermic process. Before anything will evaporate to the atmosphere, it has to gain energy, certain amount of energy, for it to be able to evaporate to the surrounding. So melting is also an example, just like as I described here in the first example I gave. So melting is also an example of endothermic process. For any substance to melt, it has to absorb energy, and a certain amount of energy for it to be able to melt. Photosynthesis is also an example of endothermic reaction. We all know what is photosynthesis, the energy that is being gotten from sunlight. So energy is trapped inside the environment of this plant. That is how they produce their own energy. Now let's look at the phase changes that occur in exothermic reaction. So when a liquid turns to solid, before a liquid turns to solid, it must lose heat to the surrounding. It must lose certain amount of heat to the surrounding. Let's assume you put your hot water inside the refrigerator. Okay, now for that hot water to become solid, to become ice, it must lose heat to the surrounding for it to become an ice. And likewise, when it comes to gas, this is a freezing process, and here is condensation. No, let's assume gas. The gas, if a condensation, what we know is that if a steam meets a cooler body, it becomes water, or it turns to water. So if a gas, before a gas turns to a water, it must lose energy to the surroundings. It must lose heat to the surrounding. Likewise, respiration here. During respiration, energy is being released in the form of ATP. This is adenosine triphosphate. So for in respiration, the energy that is being released is ATP for our cell to use. So generally, the bond, the formation of bond is an exothermic process. Let's take an example. When sodium reacts with chlorine, it forms sodium chloride. So there's a bond formation here, and energy is released to the surrounding. Likewise, most of these combustion reactions too is an exothermic process. When something is burning, or you are burning maybe your clothes or anything, there's a release of energy to the surrounding. So thanks for watching.